Okay, so in this video, we're going to continue with the third challenge in the Class Bead Game. So let's have a look at what that is. Okay, so in a previous video, we found the drier way to determine the dice game winners. So in this video, we're going to get on with refactoring the dice classes to let the user provide the number of sides of the dice and a side number that is more likely to win. And this makes it a loaded die. So it's an unfair die. The odds of each side popping up are not the same. So we'll do that in this video, and then we might do the last one in the third video. Okay, so if we want to provide the number of sides and the bias to the game, one way we could do it is we could simply add in some extra parameters here when we call the game. So we could have the number of sides here. We could have the bias side, the size that we want to favor, and we could just kind of carry those parameters through the game, and we would then go and create a cup based on those and so forth. The problem with that approach, though, is that we're putting a lot of responsibility then onto the game class. The game class then kind of needs to know about the parameters that Cup expects, got all these extra things, and those in turn are kind of passed on to the die class to create these kind of custom die. And that kind of goes against our single responsibility that we want for our classes in object oriented. Um, Also, it makes our program quite rigid. It means that if we want to do something with die or with cups, we always have to go through the game class to do it. That's more like procedural programming, where we kind of know the flow in advance. In object oriented, we want to have flexibility that users can use our classes and combine them in different ways that we can't maybe know for sure exactly what they're going to do, like in advance, but we're kind of giving them the power to be able to use our system. So one way to do that then is to kind of break it out a bit more. What we can do then is we can say, okay, we're going to give the users power to create dice. So we'll create dice here and we'll add in those parameters. So number of sides and then the bias side. So six-sided dice here with a bias for side number three, and then an eight-sided dice with a bias for number eight. And then we just got a normal generic die there. Okay, so we've got three dice being created. Then we put them into our custom cup. And then we just go on and play the game as usual, except that we're going to pass our custom cup into the game. Okay, so let's kind of follow that through then. So let's kind of start with the high level. So let's look at our game. So what we're doing is we're either going to create kind of a standard cup, just give it the number of dice that you're going to need for it, or we're going to use the custom cup that's been passed in. And then we simply kind of move on with the game. Then we can play our turn, from the cup and so on. So not really, much change to the game class, which is good. It's kind of keeping our dice customization encapsulated. Okay, so then if we move into the cup class then to kind of see how it goes. At this stage, cup actually doesn't need to know about the number of sides of the dice. It doesn't need to know about the bias. It just simply says, okay, I have a number of dice, and I'm gonna, be shook or shake myself and get a result. Again, which is nice because if we'd done it the other way, we would have had to pass those parameters through game, through cup, into the dice, and we would have had these extra things kind of clogging up cup, which would need to be tested and maintained and everything else, and would kind of distract from the real work that cup needs to do, which is basically shake. Okay, so then we go into the dice itself, and here is where the change happens, which is kind of, I guess, the right place for it to happen. So now we can initialize a dice or a die with a number of sides and with the bias side. We can also give the extent of the bias, so the number of percentage points increase in the chance of popping up, for any particular side. Um, we got a bit of validation here as well. So we're going to support, different shaped dice, but only ones that are kind of relatively likely to be used in practice. So, for example, that 20-sided dice is from Dungeons and Dragons, for example. Um, and I put an extra one in here, the 5-sided dice, which is more unusual. That'll come up later. So if the user can choose one of these numbers and get a little bit of validation here to ensure that that happens. So that kind of takes care of sides. It's fairly straightforward. And then instead of, in our previous code, we would have had 6 here, we just take that parameter for sides. Now, the bias is a bit more interesting. So what we'll do first is we'll take that percentage point and just convert it to an actual percentage, just for internal use. The percentage point is a bit handier just for the client to work with. And then we'll have a little extra function here, which will calculate the weights now for the different sides of the dice or die. And here it is, basically. What we're going to do is we're going to say the standard weight now of the sides or faces that are not biased has changed. So that they've actually reduced a bit. And what do they reduce by? Well, the probability of one of these landing face upwards now is 1 minus bias percentage over sides, right? Whatever that bias percentage is. Now, if you want to prove that to yourself, there's a little proof here where we do a little bit of algebra to kind of prove that out. That's going to be the standard, the new standard probability for any of the faces. So you can kind of take a look through that and just satisfy yourself that that actually works. Um, so we do that, and then we say, okay, for that biased face, for that one that we're favoring, we're going to add on the bias percentage onto it. That's going to have a higher chance of landing. Okay, and then if there's no bias provided, well, the weights are going to be equal. So for a 6-sided dice, those are going to be 1/6 for each of those. Okay, and then that just turns it into a list. So we have that list of weights. The final step we do here is to normalize the weights to ensure they sum to 100 or to actually 1. Now, why do we do that? Well, because when we've done the operations above, due to floating point error, some of those might be slightly rounded, and we might end up with a situation where the weights don't sum to 1. What we can do then to normalize it is we can say, okay, let's get the total sum of weights and let's rebalance the weights. They should actually sum to 1. So we'll kind of divide by that number of weights and kind of multiply by that, and we'll put it at 2 decimal points, so we don't get into as much rounding error. And we might still have a little bit of discrepancy, maybe from that rounding even. And so what we do at the final stage is we say, okay, just for that final weight, that final side of the dice or die, we're going to say, we're going to make sure that that's going to equal 1 minus the rest of the weight. So we're just ensuring that we do sum to 1, and then we check that out in the assertion. Not 100% perfect, because we're introducing a very, very slight bias that's not intended, along with the intended bias. And there are better ways to do this, but the difference is going to be very tiny. And I think this implementation will do the job for us for now anyway. So that's our implementation. And then the very final bit is when we're going to run our dice now, instead of just using randint to choose a number between 1 and 6 or one of the number of sides, what we're going to do is we're going to make a series of discrete choices. So we're going to make a series of choices, and the choices are going to be ranged in self weights. That's going to be like 1 up to the number of weights, or the number of sides. And then we can weight them then with self.weights so that the ones with higher probability are more likely to come back. And what we're doing here is we're just going to get the one with the highest returned random variable. If you see in random.choices, k, the number of items you're going to return defaults to 1. So you do get back a list, but we're going to get back a list of one of those, the index for one of those sides, and we'll just then choose the first element there of that list just to turn it back into an integer. And then we're going to just normalize that back to a one-based array. Return shows the index plus one, and that's it. That's our row done. So that's it. So we've done really kind of the rest of the challenge here. We've refactored the dice class to let the user provide the number of sides of the dice, and a side number is more likely to win. And our refactoring has tries to kind of preserve the whole kind of idea of OOP, object oriented, that we have kind of a single responsibility for each class, and that we are allowing users to use our system in a way that's kind of flexible and powerful for them. So that's kind of the idea there. And then the second thing is we actually implemented the loaded dice there. Um, so we've done a little bit of maths basically to adjust the weightings for each of those sides and then make a discrete choice between them, a weighted choice, so that the bias side is more likely to come up. So that's the story. That's what we've done here. Try it out yourself if you haven't already. Lots and lots of ways to do this. The way I've done it here is one way, and also it's a way to illustrate some of those points that we've covered. So yeah, see you in the next video.